This presentation is about aeronautical interference. It actually relates to broadcast FM sound broadcasting because it is a common concern that broadcast transmitters in the 87.5 to 108.9 megahertz band can interfere with aeronautical navigation systems that operate in the 108 to 118 megahertz band. So this demonstration talks about that and how it is analyzed and predicted in RAP. I'll start RAP using the icon on the desktop. This presentation should be of interest both to civil aviation engineers and telecom administrators at the Frequency Management Agency, and for broadcast operators that operate FM broadcast transmitters. The example relates a little, at least, to other video presentations for FM sound broadcasting, among others. So it's useful to have viewed them also, or to view them after this presentation. To start with, I'll open a project, and from the project name here we can see that it has been prepared a little. I'll explain what the preparation is. The preparation is basically that in a previous video presentation I created a new broadcast transmitter, actually quite near this VOR VHF omnidirectional range navigation facility. So let's put that broadcast station in here in this project. It is saved in the database of RAP, and well, around there. I'll just search for it. The name is the same as the village where it's located. It is this one. Add it to the project. Now it is also included in the project. I'll just make it visible also. So there it is, the new broadcast station. And a concern then is that the new broadcast station can generate interference to the navigational facilities that are shown here. The contours are the operational areas, the intended operational areas of the ILS instrument landing systems operating around 110 megahertz. And there are 3 of them. And for this demonstration I used entries in the BRIFIC database, BRIFIC FXM, where they are registered. And it's not only this, of course, this new broadcast station that could create interference. It's the combination of the new one and existing broadcasting stations in this area that can give a lot of interference. So we'll search the database, the ITU database of notified FM broadcast stations in this area to see what we find and use them also for the interference calculation. To do that, I'll first draw a circular area that includes the facilities here. Let's do it like that. I search the FM TV BRIFIC database using the search engine. That's the area, the circle definition. I'll search only for the broadcast entries, broadcast station sound entries. There are television stations also in this database, but they are not harmful in this particular case, because it's only in the adjacent band to the broadcast band where we well, it is the broadcast band that is adjacent to the navigation band that may give us interference. I'll search the Geneva 84 fragment, because if I search all of the BRIFIC database, I will have more duplicate entries, and that may give a bit strange results, or take more analysis for the demonstration to really find out if they are viable interfering cases or just spurious sort of cases that are not really harmful. So I search now by pressing OK, and it gave me 71 entries, as I can see in the status bar, 71 entries, and we'll add them to the project to perform the calculation. So I add them to the project file, the project workspace. So now we have the existing navigation facilities. They are these 4, and then in addition our new broadcast station, and in addition to that we have then the 71 existing assignments. The calculation is done to analyze these navigation facilities one by one, and I mark the station, select the appropriate tool, which is the Aeronautical interference tool, and it opens like this, a list of all the broadcasting stations in the project. I select all of them to take part as potential risks, interfering cases. There are some other settings. I won't go into detail here. The method that is applied is the ITU recommendation SM 1448-1. Is it 1448? Yeah, I think so. It is. Anyway, it's the aeronautical interference method as defined by the ITU. There are 2 types of receivers defined in the recommendation. One, old with worse performance in terms of intermodulation and adjacent channel suppression, and a newer one, 1998 ICAO, and I'll use the 1998, the better performance navigation receiver. So then I calculate, and it runs all these interfering calculations now, and I can sort on the interference margin. A negative value indicates that there is an interference risk that has been identified, and we can sort on it to find the worst. Yeah, it was test point A here that gave the worst interference, and we can check for the other types of interference. But first let's have a look what this is. It's intermodulation, and the intermodulation frequency is indicated here. The arrow power, that's the received as defined at that test point, the received power for the navigation transmitter. Here is the interfering powers from the broadcast transmitters. And at this particular point, we can see that our new station does not contribute. It's not in here. So these are the existing stations giving some interference there. To make this a little more clear, we can filter the result to just show margin less than 0, meaning interfering cases. So now there are only negative values presented. That's type A1. Type A2, no interference case exists. Type B1, no interference exists. And B2, no interference case exists. A1, though, we had interference. Let's just check a little. I'll open the help function in RAP to by pressing F1 to read what are these interfering cases really, what type of interference. So A1 is intermodulation generated in broadcast transmitters. So it is intermodulation in the installation, in the broadcasting installation. B1 is also intermodulation, but that is generated in the receiver in the airplane, the aeronautical receiver. So we have an A1. We have A1 cases, multiple A1 cases, and that is generated in the installation. Of course, it's not at all certain that this intermodulation really is generated, but the method identifies that there is a risk using the default characteristics defined in the recommendation. So to further analyze this, more calculations are needed, and that can actually be performed in another tool of RAP. But let's continue with the other stations. Let's just remember that this was a 6-7 dB or so interference indication. Running next one in the same way, and select all. Now, as you may notice, it is preset to the same two settings that when I closed the previous calculation. And let's see here, no type A1 interference. So in this case, for that particular 109.5 megahertz frequency, there was no intermodulation risk identified. And we'll check the others. No type A2, no type B1. B1 was interference in the navigation receiver. B2, no type B2. So this one, the ILS on 109.5 megahertz indicates no risk of interference. Let's check the VOR. In the same way, select all, calculate. The test points for VOR are selected differently, and the method is described in the recommendation. In the ILS case, it's basically limited by the DOC, designated operational coverage, indicated here in the map for the ILS transmitters with a yellow contour. For VOR, it's another way. Normally it's a much larger area, more test points, or more remote test points, I should say. Interference margin, okay, B2, which is desensitization of the navigation receiver. No intermodulation. No A2, which is the broadcast transmitter generating interference into the broadcasting, into the navigation band. And A1 was intermodulation again in the broadcast facility. Let's have a look here what this gives us. yeah, there was some kind of entry here that where did it go? And it indicates some kind of interference here, so it also then requires further investigation. Let's then check the last one, which is located here. The beaming is southwest. And where is the tool? Aeronautical interference. Select all, perform calculation. A lot of A1 intermodulation within the facilities and within the broadcasting facilities, broadcasting antenna tower. So we have then frequencies here that intermodulate. It is this, actually, the other station that create this can be viewed here. So it's 104 megahertz together with 94.4 megahertz. Those two will generate an intermodulation frequency at 100.1 110.1 megahertz. Actually, it's a it's a third order. It's a third order intermodulation, so it takes three stations in this case. Third order can also be generated, of course, by only 2 stations, but in this particular case it was 3. So, and this is quite an indication of a lot of interference, so it needs further analysis to really check this installation if it is up to standards, which it probably is if analysis of this type has been performed before putting these broadcast stations into operation. If it has not been considered, then it should be done to see what can be implemented to reduce this interference. So I close that. So this is close to a broadcast application. It is sometimes a bit of a difficult area of responsibility. Who is responsible for designing these facilities and check them, really to not give the interference risks to the aeronautical navigation systems. RAP is used by civil aviation administrations, so they can do this kind of analysis. It is used at telecom administrators, and they can also do this, of course. And it is used by broadcast operators, who also can do it. But then it's a matter of who is responsible within the country to really ensure that these interfering cases are treated with the proper considerations.